Scientists have spent decades searching for cleaner and more sustainable energy sources. One candidate stands out from the rest: thorium. Even so, many scientists believe thorium could become an important part of the world's future clean energy mix. What if a single element could help power human civilization for centuries? An element so abundant. That element is thorium. Today, most of the world's electricity comes from fossil fuels such as coal, oil, and natural gas. These energy sources have powered modern civilization for generations. However, there is a growing problem. These resources are finite, and as global energy demand continues to rise, finding long-term alternatives is becoming increasingly important. At the same time, burning fossil fuels releases large amounts of carbon dioxide into the atmosphere. This contributes to climate change and environmental challenges worldwide. Because of these concerns, scientists have spent decades searching for cleaner and more sustainable energy sources. One candidate stands out from the rest: thorium. But what exactly is thorium? Thorium is a naturally occurring radioactive metal found in rocks and mineral deposits across the globe. In fact, but what exactly is significantly more abundant in Earth's crust than uranium, making it an attractive resource for future energy technologies? To understand its potential, let's take a closer look at the element itself, than uranium. On the periodic table, thorium has an atomic number of 90.
Its most common and stable isotope is thorium-232. A single thorium-232 atom contains 90 protons, 90 electrons, and 142 neutrons. But here's where things become interesting. Despite its potential, thorium cannot directly sustain a nuclear chain reaction on its own. Instead, thorium is known as a fertile material, meaning it can be transformed into a different substance that can serve as nuclear fuel. So how does that transformation happen? When thorium-232 absorbs a neutron, it begins a series of nuclear changes inside a reactor. So how does that transformation happen? When thorium-232 absorbs a neutron, it eventually converted into uranium-233. Once formed, uranium-233 can undergo nuclear fission, releasing enormous amounts of energy from a relatively small amount of fuel. Because of this efficiency, many researchers believe thorium could play a major role in the next generation of nuclear power plants. Another reason for the growing interest is safety. Some advanced thorium reactor designs may offer enhanced safety features compared to certain conventional reactor technologies. Researchers also suggest that thorium fuel cycles may produce lower quantities of certain long-lived radioactive waste products, making waste management potentially easier. Beyond its technical advantages, thorium is also remarkably abundant. A significant share of the world's known thorium resources is believed to be located in India.
India's monazite-rich coastal sands, particularly along the Kerala coast, contain substantial thorium deposits. Major reserves are also found in Australia.
Despite these advantages, thorium technology has not yet been widely adopted. Developing new reactor systems requires significant research, investment, and long-term testing. Even so, many scientists believe thorium could become an important part of the world's future clean energy mix. The question is not whether thorium has potential, but whether humanity...
So what do you think? Could thorium help power the world of tomorrow? Share your thoughts in the comments and subscribe for more fascinating science and technology stories. Explore the unknown with the Novum Sphere. Subscribe for your daily dose of discovery.